Hello and welcome to the Unit 2 review video. This video will go through the Team Ziggurat sheet that you completed in class, and will also provide you some links to other videos that may help you study for your exam. So you should have your Team Ziggurat sheet out, and let's get to it. First question here says, explain why the alcohol level in a thermometer rises when it is placed in a warmer fluid. So if we think about, let's say we have a beaker here with some warm water, and inside this beaker is a thermometer. Well, at the bottom of the thermometer is the bulb, and remember that this bulb has a very thin glass outer shell. And so because of that, as particles of this liquid are moving fast, now they're moving fast because it's a warmer fluid, then they bump up against the bulb here of the thermometer. And so then the energy of these particles is transferred into the alcohol of the thermometer, and therefore the particles of the alcohol also start moving faster. Now, one of the characteristics of alcohol is that when it is heated, the particles will expand. So the particles will go from here very close together in the bulb, and they will expand and go up the tube here that is the thermometer. And so therefore, when you put a thermometer into a warm fluid, the particles of the warm fluid bounce against this glass here, which transfers energy and causes the alcohol to expand. Now, for further information about this topic, if you go to this website, tinyurl.com/9yug5k4, that will take you to the Eureka video we watched in class, which will go through an animation of exactly what's happening here. The key point to realize is that warm fluids expand and cold fluids contract. That's actually what this question number 2 is on your Team Ziggurat. It says, explain why the alcohol level in a thermometer falls when it's placed in a cooler fluid. So here we have another beaker. This time the particles are going to be moving slower, and so because of that, they're not going to bump up against the bulb of the thermometer as frequently. So therefore, the alcohol particles inside the thermometer will be moving slower, and one trait of alcohol is that when it is moving slower, the particles will contract. So let's say this is some liquid and then some ice has been dropped in. Well, the particles which were initially maybe up here because they were expanded will contract down to here, which will read as a lower temperature. Now, in these thermometers, it's important to realize that this center tube here is very, very narrow. And the reason why it's narrow is because it allows you to see expansion and contraction much better. If we had a big tube here full of alcohol, it would not rise as much because the diameter of this tube is so big. So here in a thermometer, we've got a very narrow tube, and so the alcohol rises and falls in it much more, so that we can see, oh, this is 100 degrees here, maybe this is 25 or so. Again, a good reference link for you is this link right here. Check it out. That's got the Eureka video. I highly recommend you rewatch that. Question number 3, explain how the Celsius scale was devised and why it is not appropriate to use when describing the behavior of gases. Well, if you remember the scientist Anders Celsius, he had 2 beakers. One beaker was of boiling water, and the other beaker was of freezing cold water with ice chunks in it and everything. And he had a test tube of mercury, and he put that test tube of mercury into the boiling water, and the mercury expanded, and so it rose up to here, let's say, and he said, oh, let's call this 100 degrees Celsius. And then he put that same test tube into some freezing cold water, and the mercury contracted, because when liquids get cold, they contract. And he said, oh, the mercury level's right here, let's call this 0 degrees Celsius. And so then, of course, something here would be 50, this would be 75, and so on. You can eventually figure out what every point along this thermometer is going to be. Well, then he put it under his tongue, and it ended up being right around body temperature, which I believe was 26 or 28 or so. You can look that up, and actually for further information you can watch this video here, tinyurl.com/9suhfku, and that will take you to the video where it shows him experimenting. Now, the reason why we don't use Celsius with gases is because Celsius temperatures, actually, there are negative values of those that can exist, because freezing cold water is not the coldest temperature on the in the universe. There is such thing as -10, -20, -30, and so on. And so rather we use a different scale to describe gases. And we'll learn about that in a second. Number 4 says, using particle diagrams, represent a sample of hot gas and cold gas. So let's just say we have these two boxes. These boxes should be the same volumes. And let's say that they each have, oh, I don't know, maybe 3 particles. Now the key here is to realize that hot gas and cold gas, they can have the same number of particles. It's not like hot gases have more particles and cold gases have less. The difference here in the temperature is the speed of the molecules. So if this is our hot gas here, we can represent these particles going faster by showing whoosh lines. So let's throw 3 whoosh lines here for each of these particles. Remember, they're not all going in the same direction, whoosh, whoosh, whoosh. And so we show those whoosh lines in different directions. So then if this is our cold gas, now these particles are still moving, it's just they're moving slower, so we just maybe show 1 whoosh or 2 whooshes on those. For further information about this, you can watch the Eureka video that we watched in class about condensation and evaporation. Check that out by going to tinyurl.com/9ee62nh, and that will take you to the Eureka video we watched in class.